Done. Okay. The next thing that we have, what factors would affect evaporation? So if I cause a changes in these factors, evaporation would increase or decrease. So what do you think these are? Factors affecting evaporation. What changes can I make so that evaporation it happens more rapidly or less rapidly? All right, excellent. The first one is temperature. So how would temperature affect? Hmm. And the higher the energy, so evaporation, why it happens? Because the molecules of the liquid which are there at the surface, they gain enough energy so that they leave the liquid itself. All right, they become gas molecules. So obviously higher temperature would give them more energy, and more energy would mean that it would be easier for them to escape the surface of the liquid. How would pressure affect the evaporation? Hmm. Remember, evaporation is the molecules escaping from the surface of the liquid. So, would pressure really make a difference on whether they'll escape the surface of the liquid more rapidly or less rapidly? Okay, let's write this down one by one. So, first is higher temperature. So, higher temperature. I'm not speaking anything right now. I'm just writing the explanation for this higher temperature. High temperature results in more rapid evaporation as the molecules of the liquid gain more energy. It becomes easier for them to escape the surface of the liquid. Okay. The next factor is surface area of the liquid itself. So if the surface area is large, there would be more molecules at the surface, and definitely it would become easier for them to escape. I mean, more molecules would have chance of escaping into the air. So the second is greater surface area of the liquid. Surface of the liquid results in Higher rates of evaporation at the surface of the liquid. Hence, have a chance to escape in the air. And the third factor is wind. The more wind there is, and the drier the wind, the more rapid the evaporation would be. Higher rates of evaporation. By the way, the second point is the reason that if you want to ever get rid of any liquid, any unwanted liquid, it is spilled over a larger surface area so that it evaporates more quickly. And this third point is the reason that when it's more windy, the clothes laid out to dry, they in open air, they dry more quickly because they lose their water content more easily if there is more wind. And in humid weather, it takes longer for clothes to get dry because of diffusion. If there is already higher water content in the air, uh, they wouldn't pass on as easily from the liquid or from any surface to into the air. Okay, let me know when you have written these two. Similarly, second point is the reason that if we want to make any liquid cooler, we try to put it in a larger pan because larger pan would mean more surface area, and in more surface area the molecules with more heat there at the surface, they'll evaporate and the liquid will cool more rapidly. Hmm, this. Then I think we can move on to the questions. Let me know when you have written all these three, then we'll move on to the questions. Tell me. Beginning of December. And have the mhm. And did they share the syllabus for these exams? Like which topics would be covered? Like the whole book? Hmm. All right. For the December one. For the December one. This is chapter 22, but I guess they're using a different book at your school, so it would be a different chapter. This is the portion of heat, thermal energy. Hmm. Also, let me know for this Saturday, shall we do a new topic? Or if we get finished with this heat portion, no, we won't be. Maybe in the next Thursday class. Before moving on to the next topic, I'd like to do a small revision test slash discussion. Um, Nothing serious. We'll just go through one MCQ paper. So we get a sort of revision of what we have done until now, one or two MCQ papers. And the other purpose would be that we'd have an idea of what sort of questions are actually asked in the exam. Shall we move to the questions? Hmm, Can I change what? Can't you see the question on the screen? Let me reshare the screen. Um, hmm. Can you see this now? Okay, let me do just one thing. Let me write all the formula that we have studied and that we'll be using. So the first thing that we learned and we'll use over here is um, Q is equal to MC delta theta. Hmm. Q is equal to MC delta theta. The other thing we learned was thermal capacity is equal to M times C, where C is specific heat capacity. And the last one that we learned just in this chapter, which was Q is equal to M into latent heat of vaporization. So Q is equal to mass times latent heat of vaporization, right? These are the three formula that we'd be using over here. Okay, one thing. This C is specific heat capacity. And what's specific heat capacity? Specific heat capacity is the amount of heat needed to raise temperature of 1 kg of a substance by 1 degree centigrade. Okay, amount of heat needed to raise temperature of 1 kg of a substance by 1 degree centigrade, that is specific heat capacity. And this latent heat of vaporization or latent heat of fusion, specific latent heat, this is the amount of heat that is required to change the state of matter of a substance without raising temperature. So remember we discussed in the last class that when ice is melting, at a certain point the temperature it becomes constant, and the heat given is used to change the state of matter from ice to water. The same would be for vaporization, that when I'm heating when I'm heating water, a stage would come where the temperature of water would stop rising, and the heat energy being given to water at that particular stage would be changing the state of water from water to gas, water to vapors. So this is the amount of heat that is required to change the state of matter of a substance without raising temperature. And this is the one that we'd be using in the question given, because if you look at it, it asks for that there is 10 grams of ice and what's the heat energy needed to change the state. Okay, these two are confusing. So remember, specific heat capacity is to raise temperature, and obviously when temperature is being raised, the state of matter is not changing. And in this one, this specific latent heat, it is to change state of matter. Okay. Shall I switch back to the question? Mm, mhm, hmm. 1 second. So see, uh, there is ice, and we have got 10 grams of ice. Okay, this 10 grams of ice, we want to convert it from ice to water. So first of all, which formula should I apply out of these two? Specific heat capacity or specific latent heat? Latent heat. So for 10 grams of ice, the formula, I mean, for heat energy, the formula is mass times latent heat of fusion. Latent heat of fusion over here, it would be L of F. Okay, so mass is 10 grams, and for ice, specific latent heat is 340. So 10 times 340 is 3400 joules per gram. That would be the answer. Q is equal to M into LF, and LF would be 340. So 10 into 340 would be 3400 joules per gram. Okay, the second one, how would it be done? Hmm. The second one is they've just used the play of words to make a trick on this one. Let's see if you get this right. Mhm. Temperature isn't changing, right? It's not about how much heat should be given to raise the temperature. It is how much heat should be given to change the state of matter. The formula used would be the same. The formula used would be the same. But the question is, should I take the 2300 or 340 as the specific latent heat? Excellent, excellent. Why 340 and why not 2300? Mm, one thing. The other thing is this 2300 is for conversion between water and gas, and this 340 is for conversion between uh, ice and water. So if it's from ice to water, I have to give this much heat. If it's from water to ice, I should extract this much heat. Okay, similarly from water to gas, I have to give this much heat, and if I want to convert from gas to water, I should extract this much heat so that it becomes water. We'll be using latent heat of fusion, correct? So 20 times 340 would be how much? Perfect. 6,800 joules per gram. Okay, another thing in this question, the units were aligned, but in your exam, you'll have to check that the specific latent heat, it's given in joules per gram. So either you, if the question, this thing is given in mass is given in kilograms, you'll have to first convert it into grams. Did you get it? For example, instead of 20 grams, if it were given 0.02 kilograms, I would have had to first convert it into grams so that I can use the specific heat, specific latent heat of joules per grams. The units must be aligned. That's all I'm saying. Okay. Question number two. If you could please tell me how would that be done and what would be the answer? Read the question carefully. Read the question carefully. Read the temperatures carefully, and then tell me. The equation will be the same, but see, it would be done in two steps. First, I'd apply heat. It says how much heat is needed to change 5 grams of ice at 0 degrees centigrade to water at 50 degrees centigrade. So first I'll have to apply the formula Q is equal to m into L to convert to get the energy needed to just change the state of matter. One, and then I would need the energy needed to raise the temperature from 0 to 50. Got it? And then the two energies would be added, and that would be the total energy needed. Hmm. So I said the question says how much energy is needed to change 5 grams of ice. Ice is currently at 0 degrees centigrade, and I want to convert it into water, number one, and that water must have a temperature of 50 degrees centigrade. So first I'll do the formula for conversion of ice to water. That would be step one. And in second step, I will do the formula of raising the temperature of water. Hmm. MC delta theta. And then we'll add the two energies that we get. That would be the total energy needed. Mm-hmm. It's a simple calculation. You could use the calculator of your laptop or mobile phone as well. I mean, you won't be needing fractions. It would be simple multiplication, right? Is the Holi today, or is it like on a specific day, or is it like a season for a few days? Holi. Oh, I'm sorry. I'm sorry. I'm really sorry. I'm really sorry. Yes, Diwali. Diwali. Mm-hmm. Hmm. Hmm. So, are there like any specific festivities of the occasion, or it's just like meeting people and stuff? Mm-hmm. 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 Is Diwali also a religious? Sorry, is Holi also a religious festival? Mm-hmm. 650. 650 is for what? Like total? No, total is. See, first you'll have to do 5 grams conversion. So 5 multiplied by 340. That's 1700. And then to that you will add 0 gram 0 to 50. So mass is how much? Mass is 5. C is how much? 4.2. Theta is 50. 50. 1050. 1050 plus 1700. So it's 2750. See, this is how. Mm, mhm, mhm. So it will be like this. So first of all, we'll need the energy needed. Q is equal to m into latent heat of fusion. Okay. So this is 5 grams time. Latent heat of fusion is 340. Okay, 5 times 340, which is 1700 joules. Okay, and then I'll do Q is equal to mc delta theta, because this 5 grams, now I have to increase its temperature, so it would be 5 times C for water is 4.2, because it's now water whose temperature I'm raising. So 4.2 times 50, which would be equal to 1050, and adding the two I get 2750 joules. Done. What's 2.56 for B? Mm-hmm. Did you copy the solution for A? Okay. Let's see for B. Freezer cools 200 grams of water 20 degrees centigrade to its freezing point. Freezing point is 0 degrees centigrade. So the hmm, Excellent. Correct. Correct. Next one, please. No, madam. In question, it asks you how long will it take? Question three, right? 'Either would do. If you get initially you'll get it in seconds form, so you could give it like that. 680 seconds. Perfect. Perfect. Next, please. Um, four has got just two parts. Okay. Hmm. In question 4, you'll have to calculate delta theta. First, you'll calculate that, and then you'll use the Q is equal to mc delta theta. Q is equal to mc delta theta, and then you'll calculate delta theta for aluminium.